because we clearly have lost a bit of time, there's stuff that you can do if you want to. Well, actually, no, this is what I'm going to ask you to do over the weekend. And don't worry, it's not a whole heap of work, but don't get panicky. But on here, we've got our investigation. Wah! Now, part of the investigation is going to be done. It's basically looking at graphs, but not of quadratics. So we're going to look at things that are degree 4, and you'll see them pretty nice. Now, one of the things that can help you to graph them quite nicely is a package called FX Draw. Some of you out there who have used Desmos, I'm sure that you are more than thinking, oh, I just want to use Desmos. FX Draw is really good, and it's excellent on a Windows machine. It's not too bad on a Mac. Right, but some of the stuff that I draw, the graphs, you can label and whatever, and you'll see there's a video that goes along with this. Tech help for year 11s. It's little things like finding max, mins, and a thing called a point of inflection. That's where a graph changes from being concave, right? Changes from being concave to convex, right? So it's this point here. Now, you don't have to find out the coordinates of that point. You're going to be counting how many of those there are. Now, in year 12, you actually use calculus to find those points. What we're going to do is use the graphing package and our calculators. So the bonus with FX Draw is when you hover it, it'll actually just hover around. You get your little mouse and you hover and it'll actually show you, point of inflection. So that's what the video goes through. You keep talking while I am, it's not going to end well. That's what the video goes through. So I would ask you, it's 20 minutes. It talks about how to use equation editor in Word. So if you sort of know, I know that, fast forward or just skip along. Then it has a look at the FX Draw, how to use that. And I would ask you to download, have a little bit of a play with it. And then if you want to and say, thanks, but no thanks, that's your prerogative. And you go, I'm just going to use Desmos, then you can do that. But Desmos doesn't, I don't know if you can save stuff without logging in. So I guess what I'm asking you to do is please go and have a look. And I was about to put the code and everything. It is in Teams. I popped it in there. I'll put it in here. Oh, I think I did. I'm ahead of the game. Here we go. So in the actual, I didn't put the link to line it up, so I'll pop that in there in a moment once you have done your thing. So that's weekend work, if you don't mind. All right, back to reality. Oh, and sorry, with that, what's going to happen is hopefully you're going to get some class time next week to work on the investigation, and we're wanting it before the holidays. You should see their faces. It's so cute. That's a draft, by the way, because we don't want it to be bigger than Ben-Hur. Some of you spend way too much time on this when it should be short, sharp, and shiny, right? We don't want to waste our time. It's not a research project, massive investigation thing, right? Maximum of 8 pages, and you've got a fair few graphs. So, and we'll talk about how we present it and all that sort of stuff and show you examples of ones before, but it's pretty much graph some stuff, have a look at it, see a pattern, state the pattern, move on. All right, so calm the farm. I just want you to look at your graphing package and the calculator work on the weekend. Okay? All right, and then we'll discuss the actual investigation next week. So, correct me if I'm wrong, but are you all happy with factorizing? Need a little bit more practice when there's a number in front of the x squared, yeah? Maybe, we'll see. You could also solve your quadratic by completing the square, and we're happy with that. Again, you'll have opportunities to practice, and quadratic formula, yes, and calculator. We've got the polynomial degree 2 thing. You could put it into equation solver, and of course you could graph it. Okay, what we want to try and get done today is sketching our graphs, but also looking at a thing called the sum and product, which you sort of have already done by factorizing. Okay? But this time we're going to go back the other way. So, if we have a look here, we've got our nice little equation. I'll go green. We're solving it to make it equal to 0, and so this is where we start combining everything, because one of the reasons that we want to solve it is that when we are solving, that's when we find our x-intercepts. Yeah? So if we go back and we say, I want to find my y-intercept, that's when x is 0. I'm sort of combining this sum and product with everything because they're all connected, so stay with me. You don't have to copy any of this down because you'll be practicing it in a minute. So, who can factorize for me? Two numbers, that times together, oh my god, that's the product. But when you add them together, oh, that's the sum, gives you 3. Hello. So, plus 5, negative 2. We're happy, we know this. We then finish off and we say, haha, that means x must be negative 5 and positive 2. So what you're going to look at is what happens if you get these little suckers and they want you to find the original. And you sort of go, what's the big deal? Couldn't I just go, oh, if it's minus 5, it's x plus 5. If it's 2, it's minus 2, and then expand and I've got it. Well, have a look. What's the sum of minus 5 and 2? Minus 3. And the product is minus 10. What do you notice? Anything? You can't look there, you've got to look here. Do we notice anything? You notice something? We carry on. We look over here. Here's another one that I factorized. Bloody, bloody, blah. Yes. What's the sum here? I didn't leave enough room. What's the sum? Negative 9. What's the product? Positive 18. Right, we're looking, comparing it with this, making a note. We're going, yeah. Can someone who've got the new calculators, can you tell me what is the solution to this? Because, could I factorize it? Could I factorize that? We're saying yes, we're saying no. There's a lot of We don't want to do the quad formula today. We're going to the calculator. So everybody, quick, what did you get? What does x equal? Minus 1 plus root 2. So if I had given you this and I said, find the equation, could you do it? Well, I guess I can guess. So Dylan's going, I've only given you one of the root. I haven't given you the other. Here's the rub. Do I need him to tell me what the other is? I can guess, or I can tell, not guessing. I know right now if minus 1 plus root 2 is a root, I know the other one is minus 1 take root 2 is the root. Why? Plus or minus the square root, and it's coming from our good old friend, the quadratic formula. There she blows. So that's one of the little things to lock away in your mind, is that when we've got that square root, right, the plus root, you also get the minus as well. And it's got a special name. Sorry if I'm doing your head in with the colours. Oh, well, didn't change. It's called the conjugate. Has anyone heard that word before? The conjugate. So it's just the, well, you stick the minus in front or the plus. So if I had roots 3 take root 5, what's the other root? 3 plus root 5. Right, you're allowed to assume that. We're good with that. Nothing too major. So what is this all about? It's, hey, can I then get the equation from here? So you believe me with this stuff, yes? What was the pattern? The sum? How did that link in over here? Negative. Product is the actual. Over here, negative 9, but it was positive here. 18, it was the doodad. So when we look at ones like this, we want to sum it. Now you might be going, oh, I don't want to sum. They look ugly. Look what happens. It's magic. Minus 1 plus root 2 plus minus 1 take root 2. What happens to the yucky bits? What's root 2 take root 2? Goodbye. Goodbye. Right, they're gone. What's minus 1 take 1? Minus 2. Huzzah. It's the middle term reversed. And what about the product? It's a Friday. I'll give you a break for this one, but quite honestly, if you didn't feel in the mood, you could use your calculator. So your calculator will work this out. This is how good they are. Love them. Love them. But we don't need a calculator. Minus 1 times minus 1 is 1. Why should you be shaking your head at me when I start going, oh yes, what's minus 1 times minus 2, and then what's root 2 times minus 1? Why should you be going, oh, Miss McDonald, why are you bothering? So Hamish said it's a positive and a negative. They cancel each other out. What is that called? Difference of two squares. So if you recognise it, and by the time we're done with this, you will, right? You go, oh, I don't need that middle term anymore. It just disappears every single time, right? I'm still going to write it. You would not write it. I'm just showing you that they always cancel out. And then positive times a negative is a minus. What's root 2 times root 2? 2. 1 take 2 is minus 1. And so we can, bang, get our equation. Does that make sense? Right, so let's you try a couple. So grab your books, put today's date, put a little heading, sum and product. So peeps, I'm not going to write 2 plus root 5 and 2 take root 5, right? I'm just going to write it like so. Okay? You do that. I want to find the equation, so you're going to work out the sum, you're going to state the product, and then you're going to tell me what the equation is. We'll go here. 2. I'll do this. I'm just writing some down. I'll do it for those who are maybe going, she's going too fast. Give us a number. 8. Okay, so would I write root 8? No, it would end up being 2 root 2. You gave a hard one. That was Tom. Nope. He wanted to change it. No. I'll give you a hard. No, I won't. We'll keep it nice. We'll keep it nice. Be calm. We'll change that to 4 plus or minus root 7. And we'll go 4. I really want to give you a no. Like I really want to be in a nasty one, but I won't. Okay, we're not overthinking. We're going sum. Right? When we add them together, I'd like to think that you do not, I repeat, Alex, are you listening? That you do not have to write this down like you've already realised, oh my God, every time this is just going to cancel. And so it's basically this number doubled, isn't it? But, hey, if you don't see that, hey, you write it down every single time. Sucks to be you. 2 plus root 5 times 2 take root 5 is my product. Okay? If we're on the ball, we're going 2 times 2 is 4. We're not bothering with 2 times negative root 5 because then I've got a plus 2 root 5 here. So then we're going positive times a minus is a minus, and you're going, hey, is it always going to be minus? Is it? Yes, because it's your conjugate. One's a positive, one's always going to be a negative, right? Plus, minus, and so on. Until you specky people do imaginary numbers, and then absolutely it won't always be. Anyway, take 5, so we get minus 1. We good with that? What colour haven't I used? I think we'll go fluoro green. Therefore, what is my equation? Now, can you just do this for me? Leave a little bit of a gap. It's x squared. We reverse the sign for the middle term. So the sum is the middle term reversed, correct? So minus 4x. And that one stays the same. So minus 1. Now, why did you leave a gap? Why? Why did you leave a gap? Because I asked you to. Thank you. Why did I ask you to? Because you have to pop that in and say a doesn't equal 0. It's best explained, I guess. Everyone's writing down. So if we go back here, and this is what you're about to go and do, is sketch these little suckers. So we've got minus 5 here, and we've got 2. And we've got that's got solutions of minus 5 and 2. We happy? This one has a y-intercept of minus 10, correct? So we pop that here and we go, that's minus 10. Is that the only graph that has x-intercepts of minus 5 and 2? That's going to have, they're in trouble, that's going to have x-intercepts of minus 5 and 2, isn't it? What about, they're in trouble. What about that one? What is making these different? I can have another one. What makes them skinny, wide, concave, or convex? The numbers. Which number in particular? The number in front of x squared, the leading coefficient, right? This thing here. You told me this when we first started this topic, right? The a value tells you if it's convex. I'm making hand gestures here. You can't see. Convex if it's positive, and concave if it's negatory. We happy with that? If it's a big value, that means it's skinny as, yeah. If it's less than 1 but greater than 0, so like a half, a quarter, then it's, again, I'm making hand gestures, it's like that, right? Wider. Yes, well done, but people at home can't see. So that's why you must make sure that you stick the a in front and say a can't equal 0. And remind me why a can't equal 0. Yeah, there's nothing there, right? So that's no good. And then you would have a straight line and you wouldn't have any x-intercepts or solutions. Okay, so your turn. Have a go at number 2. Okay. Shh. I don't know why you're talking. We should just do these and do them quickly. All right, what's our sum? What's our sum? -6, you're just doubling, right? What's our product? It's that thing squared. 3, because when you do the brackets, right, again, I'm hoping you don't have to write this down anymore. Oh. I just heard someone go, ew, right? -3 times -3 is 9. You're just squaring that. And positive times a minus is a minus. What's 2 root 2 times 2 root 2? So again, it's 2 root 2, yep, times 2 root 2. You can say 2 2s are 4, root 2 times root 2. I know, but some people don't know. So we've got 8 and we've got it's 1. So we're saying, therefore, y equals a x squared. Yes, I paused because I'm waiting for you to tell me. Plus 6, right? The sum is the middle term, reverse the sign. And keep the sign. A doesn't equal 0. Jazz, how can you check that you're right? Excuse me? How can we check that you're right? How on the calculator? Correct. Pop this in, right? Oops. pop this in. I would go into equation. I would go solve, and bang, you should get these as your solutions. Now this is where people, if you have borrowed calculators from the library, if you've got the older ones, they're not going to give you exact solutions. And that is why you want to try and invest in a graphics calculator. Even if you get the grey ones, you know, the black and white, but they're grey, go on Gumtree if you want to. Some people are saying they get them for 20 bucks. They're okay as well. But ideally, get one. If we Google that, sorry for people who are still using. Oh, what did I? Casio. Yeah. So we click on that top one. You probably could have even clicked on the second one, I guess. I don't know. Oh, waiting. Products. Emulator. Graphic. You guys will have to choose the Mac version to download, and you get it for 90 days. Oh, I lied. Oops. Maybe we go to the downloads. Play around. You'll find the downloads there somewhere. Submit. Go back to the other one. Do 2, 3, and 4. Check yourself with your calculator that it works. And then open Daymap and have a look at we're doing the sum and product question 1 and 2, 1 and 6, although I think I changed my mind. We're going to go 1, 5, and 6. You realise with your chatting, that's telling me that we're done and I'm ready to go, right? Sorry, just did the first one. Right, there's our sum, but we reverse the sign, product, keep the sign, and we think this is so simple. So for this one, we go, oh yes, 12. Is that correct? No. Why isn't it correct? Because there's this 4 out the front. Like if you just said 12 and 5, that would give you x squared minus 12x plus 5, and that is not the same as this because it's got that 4. So how do we deal with that? Divided by 4. You champ. You champ. So our sum will be 3 and our product will be 5 over 3. 5 over 3. 5 over 4. Done. Is this rocket science? No. Simple stuff. Okay, what about our sum over here? Again, reverse the sign, so it's positive 4 over 3. Product, do we reverse the sign? Good, we keep the sign. So it's minus 2 over 3. And we go, oh my God, this is so simple. I love it. Cast your eyes to number 3. I've just said, oh, we're looking at that. There's too many Ks, there's too many words. Nah, not going to happen. Relax. Take it slow. And what do? We underline. So the sum of the roots is twice their product. Right. So what's that going to mean? We first have to find the sum. What is the sum? Where do we find the sum again? Well, you just did it up here, but with basic numbers, yeah? So we're going to do the same thing, but you know what? Yeah, so what? There's a K in there, we'll deal. So what is my sum? And look, it's got a minus there, so all we have to do is ignore it. So our sum is going to be 1 plus K over K. Why? Because remember, we divide by the thing out the front, the leading coefficient. So far we're okay? And what about, can we find our product? Well, isn't it just that? Close. It's the 3K plus 2, but yes, we also have to divide it by k. All right, so we've at least done that. And would we say, yes, we should have all been able to do that. The k's weren't that big a deal. Not that big a deal. All right, let's get to the heart of the problem. The sum of the roots, so what's the sum? We've done it. So the sum of the roots, that's 1 plus k over k, is in maths, is equal to their product. So they're saying the sum is equal to the sum of the roots is twice their product. Oh dear, that's going to throw me. You times it by 2, that's right. Right, come on. So we're going to say 2 times 3k plus 2. I can see some of you giving me dodgy looks because you go, yeah, but miss, there's fractions. There's fractions. Do I have to worry about the fractions? Why? Same denominator. So therefore, what you are solving is 1 plus k equals 2 times 3k plus 2. Can you solve that, my friends? And my enemies? And my acquaintances? Yeah. They're almost dead on their feet, quite frankly, over here. And we're saying, yes, this is okay. We've got k. How could you then find the roots? Watching. We go to our calculator. I'm not going into the main menu. I'm going into equation, right? Polynomial, degree 2, a, b, c. What's my a? K, but what is k? Minus 3 over 5. I just plonk that straight in. Minus 3 over 5. What's my b value? Minus bracket 1 plus k. So again, I'm going to go over here. I'm going to go minus bracket 1 plus, what's k? 3 over 5. Enter. Yeah, no quadratic formula, no having to fool around with stuff. I don't even have to work out what 1 plus k is. Forget it. 3k plus 2. 3 times minus 3 over 5. Ooh, maybe I should put brackets in there. Was it plus 2? And solve 1/3 minus 1. Done. Less work for you. Less work. Try number 5. Quadratic equation again. We're not panicked by the k's this time, are we? We're going, stop that, has one root which is 2 more than the other. Find k and the other 2 roots. Well, this isn't like the one we just did. We've got 2 roots. One is 2 more than the other. So do we know what the roots are? All right, let's call them certain things. So let's call one root something. What do you want to call it? You can't call it x because we've used x. And you can't call it k because k is in there. So you've got to come up with something else. Yeah, well, I'm actually going to go Gyros. Gyros. I'm going Greek. Okay, I'm going to go alpha. And what do you think the next one would be? Yeah. You say beta, I say beta. It's all good. Pajamas, pajamas, tomato, tomato. And you know what? If you used Y and W, all good. I'm just feeling the Greek. And most of the textbooks would use Greek. All right, so these are our 2 roots. And then I go, well, that's a bit silly. Has one root which is 2 more than the other. Did I need to write beta? Because if that's alpha, what's the other one got to be? 2 more than the other. So we could call that alpha plus 2? Yes? Okay, what now? I mean, this is under the heading of sum and product. What could you do? What could you do? Sum and product. Come on, kids. Pardon? Find the sum and the product. So, your sum. What is the sum? Come on, you were a gun at this. K minus 8 all over K. Oh, have I forgotten something? The negatives, right? It's negative. What's my product? 1 minus K over K. And you go, yeah, that's great, but we don't know what it equals. Or do we? The sum, that's going to equal alpha plus 2. And this is going to equal alpha times alpha plus 2. Now, would I ask you to do this without me? No. Oof. You've got 2 unknowns, but you've got 2 equations. You're going to have to do simultaneous, but unfortunately, it's not just ax plus by, whatever. You're going to have a squared. So I'm going to be telling you now, you're probably going to have to use some substitution. So this becomes minus K plus 8. Have a look at that. Can you substitute anything? And then you've only got